Corporate finance practice problem using Excel. We're going to find the bond market rate, this time with a semi-annual bond. Get ready, it's time to take your chance with corporate finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet and would like to follow along, we are in the practice tab as opposed to the example tab. The example tab in essence being an answer key. We're going to have the information on the left-hand side. We will populate that information into the blue area on the right-hand side. We're going to be calculating the yield, or basically the market rate, given the price on the bond, with an added complexity than we've seen in prior problems, that being the semi-annual payment. So we've got the semi-annual payments at this point. Adds a good level of complexity, so it's worth taking a look at examples with the semi-annual payment. Information is going to be, we have the bond's outstanding par value, $1,500. We can imagine that being basically on the bond, the rate for the bond, 8%, and then it matures in 6 years. Now note that it's going to be semi-annual, so when we consider this information, then the percent that we're looking at on the bond, when we make the payments, we can see it as a per period payment of 8% divided by 2, or 4% per period. And then we can look at the maturities, and it matures in 6 years. If we think about that in a semi-annual term, we'd multiply it times 2, that would be 12 years. We know that the end result here, or the price, is going to be the $1,130. In prior problems, we've thought about a situation where we basically know this information up top, and we kind of have an idea of what the market rate would be, and then we came to the price. Now we know what the price is, and we want to compare that and see what the market rate would be. Before we calculate it, let's first consider, what we expect to be happening. Note that the par value is $1,500. The price is something less than that, so we sold it at a discount. What does that mean in terms of the rate? What do we expect the rate to be happening then? We expect the market rate to be above the rate on the bonds, because if, for example, we imagine selling the bonds, we're in a situation, if the market rate was higher, then the market's going to say, no, we're not going to buy your bonds at the par value because I can buy similar bonds and get a better return on them. Therefore, we would assume that the market rate is higher and we would have to sell our bonds at a discount. So we would expect then the answer to this to have a market rate that's going to be greater than the 8%. How much greater? That's what we'll have to calculate. There's a couple ways that we can do this. There is a mathematical formula that you could use, but it's a long mathematical formula. It's kind of painful, and if someone forces you to use the mathematical formula, I would think they're being kind of mean there, But we could also use Excel to kind of do this, and there's a couple ways that we can do this in Excel. First, I'm going to look at the intuitive way with the use of goal seek. Many of us, as we've seen in prior problems, have basically calculated what we would have the price to be, meaning this end result number, if we knew the market rate. And then if we know that, we can use that same calculation and then use goal seek to basically figure out and back into the market rate. So note, when we're thinking about present valuing a bond, there's two things happening. We got the present value of an annuity that will be taking place, and then the present value of the principal payment at the end. Totaling that together then gives us the price of the bond, which we know at this point is the $1,130. If we imagine what the market rate would be, we can then calculate this end price based on that imagined rate, get to a number different than this end result, unless we guessed quite well, and then we can adjust the rate to what it should be by basically brute force within Excel to just trial and error to figure the rate that it should be. Then, after doing that method, we can also use a rate function method, and we'll use that method down here. The rate function method is still a little bit complex. You got to make sure you got all your arguments in there properly, so we'll take a look at that as well. It'll be a bit more direct format to find the answer as well. So let's do the goal seek format first. I think this is the more intuitive way. We're going to say goal seek. I'm just going to make up a market rate, 5%. I'm going to calculate the total price based on that 5%, and then we'll force that 5% to then change to whatever it needs to be to get the total price to be what it's said to as the $1,130, which we'll do with the function or the use of the tool goal seek. So we'll do our present value of the annuity. This is going to be a bit more complex given the fact that it's a semi-annual payment. So be careful here. Negative present value, shift 9, rate, market rate 5%. That's what we guessed it to be. But then I got to divide it by 2 because this is the yearly rate. And we want this semi-annual rate, the 6-month rate. So that's a little bit tricky, comma. Then we have the number of periods, which is 6 years, but those are the annual years and it's semi-annual payments. We need every 6-month period. So times 2 on that one, comma, and then we have the payment, which is going to be the 1,500 times the 8%. But the 8% is the yearly percent. So that's how much interest we would have if it was annual. But we need to take that and divide it by 2 because we want that to be matching up to the 6-month periods that we have here every 6 month. And so there we have that. Let's go ahead and close it out. So it's a little tricky with those calculations, but there we have. Let's try the present value of 1 with this percent that we have over here. I'm going to say negative present value, shift 9. I'm going to do the same process, 5%. I'm going to do the same thing and take that and divide it by, divide it by 2 to give me the percent every 6 months. And then we'll say comma. Number of periods is going to be that 6, and I'm going to multiply that times 2 for 12 6-month periods. Comma, comma, because it's not an annuity getting over to the future value, which will be that 1,500. Enter. And then if I add these two up, we're getting something. I'm going to add those two up. That's what we would expect the price to be based on that 5%. It's different than that 1,130. So now we have to adjust it to pick up the 1,130. We can force that adjustment with the use of the goals. Now what that would basically do is if I just manually change this up top to 7% or something like that, we could see the adjustment 8% that's happening down here. If I change it up to 10%, we could see it adjusting down below. We're going to let GoalSeek to do that automatically to get this down to the 1,130. So I'm going to say GoalSeek change this cell, which is linked to these two, until the total gets to what I need it to be, 1,130. So we're then going to go to the Data tab. We're going to go to the Forecast section, the What If analysis, and GoalSeek. We're going to be taking this cell. We want to make that cell be what we want it to be, which is the 1,130, because that's the answer. And then we want to do that by changing this cell, the rate. Then we're going to say OK. And then it picks it up. So there it is, 1,130, okay. And we're looking 14.25. So we're looking 14.25% in order to get this calculation to be the end result of the 1,130. That's kind of in the range that we would expect because it's a market rate that's going to be greater than the rate on the bond, which would result in us issuing the bond at a discount and amount less than the par value of the 1,500. Now we can also use the rate function to do this. The rate function can be a little confusing. It's nice then to use the dialog box to do it. So let's do this with a dialog box. Go into the formulas up top. I'm going to look at the insert function and I'm looking for the rate function. If it's not there, you can type in rate and we're looking for the rate function. So now we have our dialog box, which gives us a little bit more information and it'll populate the answer down below as we do it. So if there is a problem, we can go down there and kind of pick it up. So we're going to say the number of periods. The number of periods then is going to be, the number of periods is 6 times 2, 6 years times 2 for the 12 semi-annual payments. The payment is going to be the 1,500 times the 8%. That would be for a year, however. So I'm going to take that and divide it by 2 for the semi-annual payments. The present value then is going to be the present value of the 1,130. That's the price. The future value is going to be the 1,500 at the end of this whole thing, the 1,500. Notice no result is happening down below because you have to have some payments that are some negative numbers in order to get this to work properly. The payment needs to be negative to make it work properly, and the future value needs to be negative. And then that will give us a result of the 713. So you might say, well, the 713 isn't the 1425. That's not what we expected to kind of happen, but it's giving us the rate per the periods that we're kind of looking at. So I calculate it basically as a semi-annual. So you would think that would be the rate, the 6-month rate. Multiplying times 2 would give us basically the yearly rate. So if I say, okay, for example, and then I say, let's take that rate and times 2, then we're going to get that 1425 being the yearly rate. And then we can basically double check it with our same calculations here using this rate. Let's take a look at the function. If I double click on it and just look at it this way, You can kind of plug it in with a dialog box here, without the dialog box, with just the little formula thing down below. Number of periods is that number of periods times 2. And then we have comma, and then the payment is the payment, and then divided by 2 to make it semi-annual, comma, present value, and then future value. Note the negative numbers here for the negative values that are needed to get this formula to function properly. Once we have that, we can then do our calculation again. Let's do this calculation one more time down here with the rate of that 14.25. So I'm going to say this is going to be negative present value, shift 9. The rate, I'm going to pick up this yearly rate this time. I could pick up basically the rate per period, which is the 7.13, but I'll pick up the yearly rate again divided by 2, which would give us that 7.13, comma, the number of periods, which is going to be 6 times 2, comma, and then the payment, which is going to be the 1,500 times the 8% divided by 2, and then enter. That should give us that same result. We're just calculating it again with this rate. And then we have the present value, and this is what I would recommend doing in this practice, just to make sure that you get this function basically correctly, or give another layer of check on it. Negative present value, shift 9. Rate is going to be this divided by 2. So we have this 6-month rate. Number of periods is going to be the 6 times 2, or 12, comma, comma, because it's not an annuity, picking up the payment, future value, then the 1,500. Enter. That then matching this number, adding these up, should give us our price, which should basically give us our check, our verification that we have indeed done this rate function correctly. Also note that if you did this rate function and you got to this 7.13, it should be an indication that something's not right if you're looking at the yearly rate, because that rate is less than the 8%, which would mean that you would think that this thing would be issued at a premium instead of having it at a discount. And so then you'd have to figure it out. That could be an indication that you got to do some more thinking about this and make sure that you're picking up everything that you need to be picking up. If you double check the calculation down below, you should also, pick up a double check and see that something could be off.